So yes, last question, which is electric circuits. Last question, which is electric circuits. Let's answer this one and see. Consider the second diagram below. You can see we have a second diagram here. I'm not gonna talk about the second diagram in full or break it down a lot yet. I'll break it down as I answer the question, but you can see we have it here. So let's answer the question. 7.1. 7.1. I hope you can see my stuff here. 7.1. 7.1, they say write down the reading. Oh, switch S is open. You see switch S is open. It means there's no electricity flowing here. The only reading we can have, it's on V1. Oh, I'm saying here, switch S is open. It is not closed. You see there is space here. It means there's no electricity flowing. The only reading we can have is this one, because we are measuring across the battery. So write down, it means you just write, you don't have to worry. Write down the reading on voltmeter 1. Voltmeter 1 is this one. The reading is gonna be 24 volts because there's no electricity moving around. Then 7.1.2 ammeter A1, it means here. How we're gonna, let's see, are we gonna have a reading? So let's track this. We go with this rope, we go this direction, we go this direction, and when we reach here we find that stop, restakile. This one same thing. So you see there's no connection here. Yeah, there's no connection, and then it means this one, it cannot read because we are not measuring anything. So 24 volts, 0 amperes. That's the answer, because we are measuring across this, the battery, but the ampere, the current, we cannot measure current because there is no current flowing here because the switch is open. Now the switch is closed, it means this is closed. Now it's no longer like that, it is something like this. Electricity can pass through now. So 7.2, calculate the equivalent resistance of the circuit. They are saying calculate the total resistance, so it means we need the total resistance. We mean this plus this plus this. So let's analyze that one. We have resistor 1. I'm naming them right now. I have resistor 1, which it is equals to 8 ohms. I have resistor 2, which I can say is equals to 8 ohms, and resistor 3, which, they are all equals to 8 ohms, right? So it's fine. So let me just say I have resistor 1, resistor 2, and resistor 3. But what do you see? When we come here, we reach here, we have resistor 1. Resistor 1 is in series with these two resistors, not with this one or this one. It's in series with this. But these two are not in series with each other. This one is not in series with this one. But this is in series with these two. You understand? These two are parallel, and this are series. That's what they do in exam or test. They will mix the series and the parallel. So to calculate the total, which means we are looking for RT. RT is gonna be what? We know that resistor 1, it's not in parallel with anyone, so we can say R1 okay, plus, because we know this is in series with this thing. Then this one, this group here is the ones which are in series, are in parallel. I mean, this and this, they are in parallel. R2 and R3 are in parallel. So hence now we're gonna say R1 plus open brackets of R1 over R2 plus 1 over R3. Okay, let me divide this. Let me put this here. Look what I do on this side. We're analyzing the same thing. They say we must calculate the equivalent resistance of the circuit. It means total resistance in this thing. Ne? We have this guy and this guy. Let's see. Let's first resolve this because this we can see it's in parallel. Ne? So our circuit is something, I'm drawing that part here. Then we have this part and this part, and they go out and all those things. This part is in parallel with each other. Let's resolve it. It's going to be 1 over RT equals to, I call this R2, I call this R3. So it's going to be 1 over R2 plus 1 over R3, which is 1 over R2 equals to lowest common multiple here. It is R2, R3. Here is going to be R3 plus R2. 2. We are looking for, total, man. We are looking for RT, then RT, sorry. Let me change the value here. This name, instead of RT, let me call it RP. R parallel, because I'm calculating the parallel part. I'm not discussing the other one. I'm only discussing with the parallel one. I want the total resistance on the parallel resistors. Again? Yes. So it's RP. So now RP equals to, we eliminate 1 over RP. We take the reciprocal. It means we're gonna swipe them. So it's gonna be RP, it is equals to R2 R3 over R3 plus R2. So it means is to get the value of these two. Okay? So to get the value of these two, now we're gonna substitute and say RP equals to, what is R2? 8. What is R3? 8. Divide by 8 plus 8. This becomes 8 times 8 kibukai. When I'm waiting for you to calculate, like it's like in class now. 8 times 8 is how much? I don't know. 8 times 8, it is 64. So it is 64 divided by 8 plus 8, 16. 8 plus 8, it is 16. Therefore, 64 divided by 16, it is equals to 4 ohms. So it means this, the total resistance here, it is 4. For these two, they total up to 4. So when I go back to my original equation here, you can see, Uri, I only calculated this part. So when I bring this down, I say, now my total resistance, it is R1. R1 is which one? Is this one, which I haven't touched this. I haven't touched this one. Okay, this is R1 plus R parallel, because these two are parallel. Mara, these together are series. Because when we get here, that's where we split. Are you with me? Yes. I hope you're with me. Then, what is R1? 8. What is RP? This one here, it's 4. Then the total resistance, it is 12 ohms. And we got the answer. So, alright, now let's continue. 7.3. 7.3. This is the answer for the previous one. 7.3. Calculate the reading on voltmeter 2. We need the reading here. Ne? So when we need the reading here, what do we have here? There we have resistance, which is 8 ohms. Okay? We have V2, of which we don't know yet. Okay? And we have what? We have, in order for us to get V2, it means V2, it is equals to what? R. What's the name of R there? We called it R1. Okay? Remember I said this one, let's call it R1. Okay? R1, this is this V over IR. I'm sure this is the correct one, if I'm not mistaken. So to get V, it is I R. V2, in order for us to get V2, we need the current there at V2 and we need the resistance there. So how are we gonna get that? Reshotaka current there. How do we get this current? So to get this current on that part, we're gonna say, remember, in a series, current is the same everywhere. It means the current which we're gonna get here is the current across everything. It's just like when it reaches here, it splits. But now since we have RT, we have the total resistance in this thing, we can say here, we can come here and say, if we have RT, which is equals to 12 ohms, and we have VT, which is equals to 24 volts, what will be IT? IT is gonna be what? It's gonna be VT divided by RT, which is equals to 24 divided by 12, which is 2 amperes. So it means now the total current in this circuit, it is what? It is 2 amperes. Then after we got 2 amperes, to calculate our to answer our question, to answer the question of like what is the reading on voltmeter 2, we're gonna say what? We're gonna say V2, it is equals to IR1. Why? V2 is because we are measuring across V2. What is the value of I? It is 2. Why 2? Because current, it is the same in a series circuit everywhere. The current, which is total current, is going to be the same here. Are you with me? Yes, but it's going to be split between these two. But for now, the current is the same. Then what about R1? R1, I said this, let's name this R1. Then time is 8. Then the answer here, it is what? It is 16 volts. So this is the answer we get. You got it? Let's move to the next one now. 7.4. Then 7.4. How do the readings on ammeter A2 and A3 compare with each other? Okay, how will they compare with each other, guys? This is how they're gonna go compare with each other. And get this A1. When it reaches here, it splits to be this direction and to be this direction. Then it means that A1, it is equal to A2 plus A3. Are you with me? But in this case, what is the, if we want to calculate A1, it means we need what? We need voltage and voltage on, A2, we need voltage, which means there, we need the voltage there, and we also need the resistance there. We also need the voltage there and also need the resistance there. Current and resistance, they have a relationship. The relationship is inversely proportional. You increase current, it means you decrease resistance. How? Let me explain this. Look at the pipe of water. Let's take, we have a pipe of water. Ne? We have a tap of water. We have a tap of water. It's this big. And the water which flows, we call that current. And the size of the pipe, we call it resistance. Okay? So, if we increase the size, if we increase the size of the pipe, it means we're gonna have a bigger pipe, right? And if we increase the size of the pipe, what happens? It means we're gonna have more water flowing. And when we increase the size of the pipe, it means we are decreasing resistance. And get resistance is what? It's when we decrease it. It's like when we make it smaller, it means we are making to be resistant. So the relationship between current and resistance is that when current increases, resistance decreases. But in this case, they're saying that how do the readings on A2 and A3 compare with each other? They're gonna be the same. Why the same? Because this is 8 ohms and this is 8 ohms. Yes. And the voltage across here, it is the same since it's parallel. So the answer, it is the same. 7.5. I'm tired. 7.5. The graph below shows the relationship between resistance and the length of a conducting wire. Okay, so let's look at the graph. This graph, resistance and the length of the wire. It means that the bigger the wire, the bigger the resistance. Write down the relationship between resistance and the length of the conducting wire. As I said, the bigger the wire, the bigger the resistance. As the wire increases, the resistance also increases. Determine the resistance of wire with a length of 30 millimeters. So you're gonna go to 30 millimeter, you measure, and you reach here, you find it's somewhere here, and here you measure it's somewhere here. Then you're gonna choose or is 1,3 or something like that. But hey, I'm tired. I think I've done my job.